Welcome back to our Stoichiometry quantitative and qualitative analysis series. This extract is gotten from Jam Remix. Let's get straight into it. Please note, what are you supposed to do while practicing these questions with us? I'm going to be giving out points for you to jot down. You jot those points down while practicing with us. Let's get straight into it. The first question here has to do with, I'll call it demonstration, meaning we need to solve it. Demonstration. Second question, demonstration. Third questions. 3 solutions containing carbonate, sulfate, and sulfides ion respectively. One test that will identify just one of them completely is by addition of each of them. What do you need to add to each of them? Let's see. Barium chloride solution, dilute hydrochloric acid, lead nitrate solution, calcium. Number 3 is option B. When you add addition of hydrochloric acid will produce a colorless gas, and in this case this colorless gas will be hydrogen sulfide. So jot down addition of hydrochloric acid, addition of dilute hydrochloric acid would produce a colorless gas, which is also known as hydrogen sulfide or H2S. It has the characteristic repulsive odor of a rotten egg. So number 3 is B. So 3 solutions. One contains carbonate, another one contains sulfate, another one contains sulfide ion. So when you add HCl to this sulfate, you get hydrogen sulfide. Next, when you have hydrogen sulfide. Number 4, if hydrogen sulfide gas, remember we said just now that it smells like a rotten egg, is passed into a solution of pure iron chloride, a yellow deposit appears. If the deposit is filtered, a pale green solution is left behind. The pale green solution contains what? Now, let's write down iron 3 chloride, open bracket, FeCl3 equals yellow. So the color is kind of yellow. Next, write iron 2 chloride is green. Iron 2 chloride is green in color. So iron 2 chloride is FeCl2. That one is greenish in color. So what really happens here is that if hydrogen sulfide now gas, if it's passed into a solution of pure iron chloride, they don't tell us the type of iron chloride. They say, a yellow deposit appear. Don't forget we say yellow deposit. Yellow deposit is iron 3 chloride. If the deposit is filtered, a pale green solution is left behind, iron 2 chloride. The pale green solution is iron 2 chloride. Number 4 is option E, iron 2 chloride. So what really happens in this reaction is that iron 3 chloride is reduced to yellow iron 3 chloride is reduced to pale green iron 2 chloride by hydrogen sulfide. Open bracket, hydrogen sulfide is a reducing agent. Question 5. In titration involving sodium hydroxide na base solution and a dilute hydrochloric acid, where would you place the base? You place the base in the conical flask. In titration, you place the base in the conical flask. Why? Right. The pipette is PIPETTE. The pipette is used to measure the base into the conical flask. Number 6. The solution of a sample in a tube will be identified as a chloride if it gives. How do you identify chloride? If it gives. Now I want us to jot down this point. Let's see if we could pick out the correct answer. Then I would give the note. So, okay, and barium chloride solutions, a white precipitate. A white precipitate with acidified with HNO3 and then silver nitrate solution is added. So right, acidification process of HNO3. I want you to jot it down like this. Test for chlorides, because from our question here, number 6, you could see they say the solution of a sample in a tube will be identified as a chloride when it gives. Number 6, when it gives a white precipitate with acidified dilute HNO3 and then silver nitrate. So right, test for chloride. First, acidification with dilute HNO3, which then gives a white precipitate with silver nitrate, So if you want test for chloride, you go first put acid. If you want test for something for chemistry like this, I will use page make you understand. How they take the test for chloride? How you go take no say this thing wey dey inside this container or this flask na this beaker or this flask na chloride. The first thing wey you go do be say you go acidify am, meaning say you go add acid. So the addition of the acid na they call HNO3. So you go add HNO3 first, okay? Then you go add silver nitrate, AgNO3. You go add acid to the item. You don't know what the item be. You go add acid, then you can add AgNO3. If it gives you white precipitate, it means say na chloride be that. Now, right. In testing for chloride, you either use AgNO3 or Pb open bracket NO3 close bracket 2. That one is called lead nitrate. You could either use the both of them. A white precipitate of lead chloride is formed, which is soluble when hot but insoluble when cold. So you don't hear now. If they say test for chloride for chemistry, first things first, they go acidify them with triazonitrate 5 acid, which is HNO3. Then you can add another thing to check. You don't know the thing. We add acid first, then you can add silver nitrate or you go add lead nitrate. You give you a white precipitate, and so they take the test for chlorides. Number 7. A piece of metal is dissolved in nitric acid, and the resulting solution is treated with a small quantity of sodium hydroxide to produce a white precipitate. Once you hear white precipitate, may your mind first go that silver we'll talk about. Are you sure don't be chloride they talk about? More weight, which redissolves on the addition of excess alkaline. The precipitate B, when ignited in a crucible, produces the oxide of the metal M. The metal M is dash. You see, this kind of question I make people they say they hate chemistry, but hard. So more go again. I go use pidgin now. They say a piece of metal M. So metal, they put metal inside acid. You dey hear so they put metal. A piece of metal M is dissolved in nitric acid, and the resulting solution is treated with small quantity of sodium hydroxide. So what you can later get, then treat them with small quantity of sodium hydroxide to produce a white precipitate, which redissolves on the addition of excess alkaline. So guess so the metal you react them first with acid. You still react them with base. See, they react them with nitric acid. They also treat them with sodium hydroxide. Now wetin they treat with wetin they treat with acid and also base at the same time. So it's supposed to come to your mind. Amphoteric. Things where they amphoteric, and they treat with both of them. So don't forget, it could literally be aluminium, it could be zinc. But let's go further. So it could either be aluminium or zinc. But see, let's continue. A piece of metal M dissolves in nitric acid, and the resulting solution is treated with small quantity of sodium hydroxide. So acid and base at the same time is either zinc or aluminium. Go further. To produce a white precipitate B, white precipitate go push us say na zinc, but wait, which dissolves on the addition of excess alkaline. That's zinc again. The precipitate B, when ignited in a crucible, produces the oxide of the metal. Aluminium will not produce oxide of the metal. So the correct answer is zinc. But I want to explain few things. I want me to write some things for me first. They say a piece of metal. So may you write for me. whenever you react, write them like this. Whenever you react zinc and, like a statement, whenever you react zinc and HNO3, you would get zinc nitrate, water, and ammonium nitrate. So I'll talk wetin be zinc nitrate for you now for chemical formula. Zinc nitrate now Zn open bracket NO3 close bracket 2. Then ammonium nitrate now NH4NO3. You get. So they went further. They say they went further. See, a piece of metal is dissolved in nitric acid. So once we dissolve zinc in nitric acid, I don't already tell now what we will get. We'll get zinc nitrate, we'll get water, we'll get ammonium nitrate. Then they say, and the resulting solution is treated with small quantity of sodium hydroxide. So the zinc nitrate, go down and write now. Zinc nitrate, Zn open bracket NO3 close bracket 2, reacting with sodium hydroxide would give us zinc hydroxide, and sodium nitrate. Now, what's the formula for zinc nitrate? I'll go again. So I want you to go to the next line and write these chemical formulas out for me. Zn open bracket NO3 close bracket 2 plus 2 NaOH. Then put that arrow. Gives us, now to the product side, Zn open bracket OH close bracket 2 plus 2 NaNO3. Do you understand? So zinc nitrate reacting with sodium hydroxide would give us zinc hydroxide and sodium nitrate. Now, this zinc hydroxide now be the white precipitate. So where did they talk? So, but see our question, they say B resolve in excess alkaline. So they redissolve them again. So go to the next line and write zinc hydroxide, which is Zn open bracket OH close bracket 2 plus NaOH will now give you Na2Zn open bracket OH close bracket 4. That's the precipitate that's been dissolved. So let's go back to the question. They say a piece of metal M, which is zinc, is dissolved in nitric acid, and the resulting solution is treated with small quantity of sodium hydroxide. When it dissolves in nitric acid, we'll get zinc nitrate, we'll get water, and we'll get ammonium nitrate. Now they later dissolve that zinc nitrate into sodium hydroxide again to produce a white precipitate. Zinc hydroxide is a white precipitate, ZnOH close bracket 2. Be looking at your notes while I'm explaining it again now. Which redissolves on the addition of SS alkaline. Now be the next last equation. Zn open bracket OH close bracket 2 plus NaOH. The precipitate B, when ignited in a crucible, produces the oxide of the metal. The metal is zinc. Now, that precipitate, which the last chemical formula I gave you, which is Na2Zn open bracket OH close bracket 4. When you heat that thing, it will give you the oxide of the metal, and that metal na zinc. If you say you jot the points down, go through them again and again. If you say you no jot them down, rewind, go through it again, you go grab them. Then if you still get questions, you drop it on the WhatsApp group for us. I'll be there to take your questions. Number 8. A solution X on mixing with CO, remember we say chloride, nitrate, you go acidify them with HNO3. They won't repeat them more. A solution X on mixing with silver nitrate solution gives a white precipitate. Don't forget, silver nitrate will give white precipitate, lead nitrate will give white precipitate when cold, and it will change when warm, and it will change when cold. Don't forget to, sorry, it will be soluble when cold but insoluble. It's soluble when hot but insoluble when it is cold. That's lead chloride. But so come back to question 8. A solution X on mixing with silver nitrate. Whenever you ever hear of silver nitrate, make your mind just they go chloride. But wait, solution gives a white precipitate solution in, this is ammonia, comma, full stop. A solution Y when added to X also gives a white precipitate which is soluble on boiling. soluble on boiling. They tell you say na lead be that. Solution Y contains, you see am, very very cheap. Solution Y contains lead ion, lead ion, lead ion. The both of them na test for chloride, whether you use lead or you use silver, you get. But lead own, if e dey soluble when hot and insoluble when cold. So see am, they say a solution X on mixing with silver nitrate. A solution X, when you mix am with silver nitrate, that's chloride. When you mix chloride with silver nitrate solution, e go give you a white precipitate that is soluble in ammonia. You get. Chlorides are soluble in ammonia, no forget. Now moving forward, a solution Y, they're talking about another solution now. We are done with X. When added to X, which is chloride again, also gives a white precipitate, which is soluble on boiling. Solution Y contains lead ion. So that's lead ion. Moving for 9 demonstration, 10 demonstration, 11. This one talks about, they're asking you for chemical equation. They want to test your knowledge on this. 11, right? Say which of the following reaction is correct as written? Which of the following reaction is correct as written? You have your formula option A to this one now talks about balancing of chemical equations when you balanced it in stoichiometry. If you check, we are having option D, C. This is sodium hydroxide and H2SO4. You're having water and you're having a salt. This is an acid salt, NaHSO4 plus H2O. Number 11 is D. Number 12, demonstration. Most of the questions in this chapter they are based on demonstration, and we have them solved also. So solved 14, 16. Yes. All right. Let's try 19. X is crystalline salt of sodium. A solution of X in water turns litmus red and produces a gas which turns lime water milky. Whenever you hear lime water milky, just know that it is carbon dioxide. So write down lime water milky equals CO2. When added to sodium carbonate with barium chloride solution, they say X gives a white precipitate which is insoluble in dilute hydrochloric acid. X is what? Now, some other person might be like, this is why I don't like chemistry. But now, what make chemistry dey easier than other subjects be this. You just need to first understand them. So, X is a crystalline salt of sodium. So the item na salt of sodium. If the item na salt of sodium, okay, they even ask you to be X. X is a crystalline salt of sodium, comma, full stop. A solution of X in water turns red litmus. If it turns red litmus, it means you need to have acid in it. So this one no get acid. This one are normal salt. This one na acid salt. This one too na acid salt. This other one's na normal salt. So the answer is between option B and option C. Now between the both of them, because they say they turn red litmus. If they turn in water turns litmus red. If it turns litmus red, it's either option B or option C. We need a strong one, because this CO3 is a weak acid. SO4 is a strong acid. So our correct answer is actually option C. But I want to give the equation, so we'll go back and take the equation again. And we will stop this clip here and continue from another clip, so it's not too long. X is a crystalline salt of sodium. So NaHSO4 9BX. A solution of X in water, if you put a solution of this one, if you mix water with this one, it go turn litmus red, meaning say you get acid. That I take no say you get acid. Whenever you see something like this, see NaH, whenever you see this H in between, they call them acid salt. So even this one too na acid salt, but this one na strong acid salt and this one na weak acid salt. Person you ask me now, say how you take know say na weak and strong? Simple. CO3, anyone wey you see with CO3 na weak acid salt, anyone at all. Then anyone wey you see with SO4 na strong acid salt. Hope I don establish that one. So good. So this option C here, NaHSO4 is crystalline salt of sodium. A solution of that same thing in water turns litmus red. When and produces a gas which turns lime water milky. Now it don't become a little bit different. They say they produce a gas which turns lime water milky. Now this one I suppose produce a gas which turns lime water milky, because out of CO3 here we go fit get CO2, and as CO2 they turn lime water milky. But calm down, more continue the equation may you see. Which and produces a gas which turns lime water milky. They say when added to sodium carbonate. Since they say when added to sodium carbonate, meaning say, oh, not necessarily this one again, now still this one. So first, X is a crystalline salt, option C. A solution of X in water turns good. Option B and option C are both crystalline salt. Option B and option C can both produce red litmus, and they can this one can readily produce CO2, which will turn lime water milky. But they say it only turns lime water produces a gas which turns lime water milky when you add them to sodium carbonate. So if you be say that they talk about sodium carbonate now they call Na2CO3. You get? So when you add this NaHSO4 to Na2CO3, you get another thing which I want to give you now. So write down for me. 2NaHSO4, which is our option C, plus Na2CO3 equals 2Na2SO4 plus H2O plus CO2. The CO2 now they turn lime water milky. Now, when they say was added to a sodium carbonate, the sodium carbonate now be Na2CO3. You can be labeling your own like that, the naming of it, so you sabi the name is small. NaHSO4 is an acid salt. It's called sodium hydrogen tetrasulfate 6. Now be that, now the salt be that. Then now be that one name. The Na2CO3 where you don't jot down, now they call sodium carbonate. Good. Then the 2Na2SO4 where you don't jot down, now they call sodium sulfate. Then H2O they call them water, CO2 they call them carbon 4 oxide. That one they turn lime water milky. They say when added to sodium carbonate, now they move on. They say with barium chloride solution, X will still give a white precipitate which is insoluble in dilute hydrochloric acid. Definitely is a sulfate, because when they don't bring barium in, they use that barium, they test for sulfates. We'll keep it at that, make a note to confuse you. So now the questions we will take be that. From our next video, we'll continue from question 20 upwards. The notes where you don't fit jot down while watching this video, I would like make you snap them and send to me. I gave notes, I gave some a little bit of chemical equations, etc. One other thing where I want me you do, the parts where you know really get, you send them to the submit group. Don't forget, say after each clips we will take a speed test on it. Thanks for watching. I will see you in the next video. Please note, we do run classes to help you prepare for your next exam. If you would like to be part of our class, I'll leave a link in the description box that you could use to chat with me directly, and also from there you could enroll to our classes. Thanks for watching. I'll see you for the next video.